today's session we are going to see stereoisomerism. Okay, stereoisomerism. Iso means same, mer means unit. Okay, sometimes the complex will be a same chemical formulas, but its arrangement of the spatial arrangement is different. Okay, that is a stereo. Okay, so definition: same chemical formula in connecting between central metal atom of ligands, but different in spatial arrangement of ligands in three-dimensional space. Okay, so this is stereoisomerism. Stereoisomerism are classified into geometrical isomerism and optical isomerism. So geometrical isomerisms, suppose coordination number 4, coordination number 4 means, so it would be a tetrahedral or square planar, okay, square planar. Okay, so the case 1, okay, suppose coordination number 6 means that is a octahedral complex, okay, octahedral complex. Okay, so here, so case 1 for tetrahedral complex, suppose we may consider this is a tetrahedral complex. So A, B, this is back of the plane, C and D. So here the bond angle between this A and D is 109 degree and 28 minute. Here also this bond angle between C and D and B and C and A. So all the bond angles are same. Okay, suppose we flip on to this, rotate this to that. Okay, so what happened? So this D goes to there. Okay, A comes here. Okay, so there is, we cannot see any spatial difference. So why? Because of the bond angle for tetrahedral complex, the bond angle would be same in for all the this complex. Okay, so there is no changes of the spatial arrangements. So we cannot see the GI means geometrical isomerisms, we cannot see. Okay, so there is no geometrical isomerism exists in tetrahedral complex. Okay, so case 2 for square planar complex. Okay, suppose MA4 plus or minus. Okay, so this A is 4 number of ligands, coordination number is 4, directly attached to this central metal atom. How it is this for central metal atom? So all the ligands are same. Okay, so here one thing is we can see, noticed, that is homoleptic complexes we cannot see the geometrical isomerisms. Okay, geometrical isomerism for this case also no, because here suppose we can flip on to this. Okay, what happened? This A goes there and this A comes here. So here suppose adjacent positions same, so the ligands are same. When we have to rotate this type ligands, so there is no change, there is no spatial difference takes place. For this case also geometrical isomerism is for same type of ligand or homoleptic complexes will not see geometrical isomerism. Okay, so second one, suppose A2B2, okay, complex. So let me take diamine and dichlorido platinum 2 complex. Okay, so how it is? Platinum, suppose here I can introduce the new terms for cis form and trans form. What do you mean cis form? When a central metal atom, so the ligands present in the adjacent positions, okay, so that is this adjacent positions or this side. Okay, that is cis form. Okay, at the same time ligands present in the opposite side. Okay, ligands present in the opposite direction. Okay, here this B is perpendicular this B and this A is perpendicular this A. So that is trans to each other. This is called trans. Okay, when a central metal atom, the ligands present in the adjacent positions, that is called cis isomer. At the same time the ligands present in the opposite positions, that is a trans isomer. Here you see that platinum, the diamine and the 2-chloride. Okay, 2-chloride. Here the amine groups are present at the adjacent, lie on the same side, that is cis isomer. Here the amine groups are opposite to each other. This amine perpendicular this amine, this chloride is perpendicular this chloride, because this some rotations takes place. The spatial arrangement also different. Okay, so this case for the cis isomer used for anti-cancer, but this trans isomer, it is toxic, highly inactive. Okay, highly inactive, because so we may not consider the same here, that is the same, the complex formula is the same, the arrangement also same, but different spatial arrangements, its property also completely different, and its functions also completely different. So this here the cis isomer used for the treatment of anti-cancer, but here it is a different, it is a toxic one. Okay, so the students, this is what the objective of geometrical isomerism, cis and trans. Okay, so it is not one and the same, it's a spatial difference is different, its the functions also different. Okay, okay children, next case 3, the stereoisomerism exists in octahedral complex. Okay, suppose Ma2B4. Okay, so let me take an example for tetraamine dichloride of cobalt. Okay, so here the cobalt is central metal atom, 4 amine groups are present, and this chloride ion oriented in different manner. Okay, for cis form and the trans form. So for this case, why it is cis form? Because this chloride ion in the octahedral complex, this chloride ion present in the adjacent positions. So we may call this is a cis isomer. At the same time, the different orientations for here the octahedral complex, the chloride ion opposite to each other of the central metal atom. So this is called trans isomer. So how many Gi? For Gi equal to 2. One is cis form and another one is trans form. Okay. Suppose this is and all unidentate ligand directly attached to the central metal atom. Okay. Suppose the En, it is a bidentate ligand. Okay. So how can we draw this octahedral structure for this cis form and trans form? This is central metal atom. 1, 2, 3, 4, 5, 6. This is octahedral shape. Okay. So here 2 chloride ion. So chlorine, and this is bidentate ligand. So connected between these two, En and this En. Okay. So this is bidentate. This is form cis isomer. Why it is cis isomer? Because this chloride is present at the adjacent positions, same side. Okay. So how can you draw this for trans isomer? CO 1, 2, 3, 4, 5, 6. Okay. So that is the orientations is different for this case, Cl and here Cl, and the En is a bidentate ligand, that is connected between these two. Okay. So this is trans form. This is trans form. Okay. This is for case bidentate ligands. Okay. So another one type is, it is a special Ma3B3. Okay. So that is the amine and also the nitrite for the ligands, 2 different ligands attached with the central metal atom. Here you see that this is octahedral complex. The same donor groups or donor atoms present at the adjacent position of the octahedral complex. So we may call that is facial isomer. Okay, you see that. So NO2, same donor groups present at the face of the octahedral complex, that is facial isomer. Here another one is meridional. Meridional means, I think you studied in geography, that is the connected between north pole and south pole at the through this one semicircle. Okay, that is meridian. Okay, here like also same for octahedral complex, this is one pole and this is one pole. So that same donor group at a semicircle like this through this NO2, This is called meridional. The donor groups present at the meridian site of the octahedral complex. Okay. So that is called meridional isomer. Okay children. I hope you this understood further.